practice final from chapters 5 through 8. So for number 1, you just have to combine like terms. So we just want to do the 5 and the negative 9 to make the negative 4x squared, negative 6 and negative 8 together to make negative 14 xy squareds. The xy terms, the positive 7, negative 7, will just eliminate each other. The 8 and the 6 for the y's make a 14y. The negative 9, negative 5 will make a negative 14. For 2, we need to distribute the negative sign to change all the signs on the back half. So this whole beginning part just stays the way it is. And then the minus in the middle has to change everything. So this needs to become a plus. This plus a minus, the minus a plus, this plus a minus, this minus a plus, and then again we'll combine like terms, just like we did on number 1. For 3, we're looking to do a lengthy version of foiling. We need to have each of these 3 things multiply each of those 3 things and temporarily get 9 things. So we need the 3x times that, 3x times this, 3x times this, and then move on and use the 4y. 4y multiply this. I'm going to put that under the 15 because they both have x and y's. I'll keep my like terms lined up. There will be a 20y squared from 4y multiplying this. There would be a 28y from the 7 and the 4y. And then use the 5. 5 times the 3x is a 15x. 5 times 5y is a 25y. 5 times 7, there'd be a 35. I'll just throw that over there because I'm running out of room. And then we would just combine like terms. 9x squared has nothing like, but the xy's make a 27. The x's make a 36. The y's make a 53. Doesn't matter what order you put them in, just make sure you have everything there. 4 is just regular foiling. Again, when we FOIL, the F stands for the firsts, so that makes a 10x squared. O for outside makes a 12x. I stands for the insides, that makes a 25x. The L stands for the lasts, that would be a 30. And then we want to combine those because those are like terms, that'll make a 37. For 5 to square, you could either put 2 of them side by side and FOIL as we did up above, or you could remember there's a pattern to do x times itself, copy the sign. This times this, but double. X times 2 is 2x, double that to get 4x. Always a plus when we square at the end. 2 times 2 at the end would get us a 4. 6 you can FOIL, or you could remember a trick for this one when the signs are different that you don't have to worry about the inside and outside terms. Just worry about firsts and lasts. 7, we start to factor. So 7, the rule is when we factor things with x squareds, we generally go x and x. With a plus here, these signs have to be the same as this. So both pluses. And when the signs are the same, we try to add to make the middle while thinking of multiplication and times tables, pairs of numbers to make 25. 5 and 5 is the only way to add to 10 while multiplying to 25. But we'd rather not write this answer this way. We'd rather write this as x plus 5 squared as it is on the key. Hopefully you have your key nearby looking at the video and the answer key at the same time. For 8, 8's just a difference of squares, so we make 2 sets of parentheses that are the same. Cut the powers in half to both have x's, root the number to have a couple of 5's. 9, we're factoring a GCF, so we look for a number that goes into both of these, which would be 20. We see if there's any variables that are the same on both, and they both have a z. And then we divide each item by that. 20 divided by 20 is gone. X and z, if we take off the z, just leaves us an x. After the minus, we're again dividing. 40 divided by 20 is 2. And if there's a yz and we take off a c, that just leaves a y. 10, anytime there's a number in front of the x squared, if you can't factor it off, you have to just start guessing stuff. 3x and x is the only way to get 3x squared, so that's not much of a guess. Again, if the sign's a plus at the end, we know these are the same as this, so those are both pluses, not a lot of guess for that. But then for the 10, you just get stuck guessing. You could try 10 and 1, you could try 1 and 10, those would both fail. 2 and 5 in that order are the only pair that'll work because you have to FOIL to check that guess. These two make 2x, those two make 15x if you multiply, and 15 and 2 is the only way to make the 17. 11, if you have 4 terms, we usually look to do a thing called factoring by grouping. You see what's in common to the first two, which is a q, leaving x plus y. We look what's in common to the back two, but we'd like to leave a matching x plus y for this to work. So it's not just enough for us to take off the r, we need to also take off a negative, because taking off a negative is just like up here when I put in the negative to distribute it, it switches those signs. And then we're going to get two groups. The x plus y is one of the groups that we can see, it was already here twice, just keep that group. The other group would be q minus r. Flipping the page, 12 and 13 say to factor completely. These are problems where we'll have to factor, and then we'll have to factor again. So on 12, 12 starts off a lot like number 8. It's a difference of squares. If the power is an even power, we look to cut that in half. We look to do different signs on this type of problem. And to get 1, it has to be 1 times 1. But if that's all you do, you're not done. Because we also have factored cubed problems during the course of the year. And this is a cubed problem. So for cubed problems, we divide by 3 on the power. We copy the sign. We cube root the 1, which is still 1. But if we had like an 8, an 8 would turn into 2, because 2 times 2 times 2 is 8. Then we build the second factor from the first. Take y times itself, do a different sign, multiply the 1 and the y together, always do a plus, and then finish with 1 times 1, which is still 1. This is also a cubed problem, just with different signs. So we go same pattern. Power divides 3, copy sign, cube root 1, y times y, a different sign, 1 times y, always plus, and 1 times 1, and these 4 factors are the answer. The y to the fourth problem, the next one is a similar problem. We cut power in half again to start. It's a difference of squares again. Difference of squares means even power, a subtract, and a number we can square root. So we will square root the 81 to get 9s. 1 plus, 1 minus. This is done. Okay, this won't factor more, but this will. So we need to go again. We'll need to keep the y squared plus 9, but do this as a difference of squares again. Power cuts in half, signs are different. 9 we square root to get 3s, and those 3 things are the answer there on 13. 14, you want to read the story and just one word at a time, translate it to math. So it says 4 times, so we'll multiply. Square of a number would be x squared. Is always equals 21. More than is an add. 8 times the number is an 8x. Throw that in the first blank, that's going to get you some of the points. For this kind of problem, we've always gotten these equal to 0. So subtract the 8x, subtract the 21 to get it equal to 0. And then we would try to factor. With 4x squared, we just have to guess. I'm going to think 2x probably. With a minus, we'll go different signs. And then we'll just have to guess some numbers that multiply to 21 and hope we get it right. So I'm thinking 7 and 3. I'm going to go 7 and 3. To be sure that's right, we have to FOIL. This would make a 6x. Those make a negative 14x. Together that is negative 8x, and so on right. For the answers for this, we always switch the sign of the plain old number, so negative 3, but put it on top of 2. So this would be a positive 7 on top of the 2. 15, the picture probably helps. Draw a rectangle for the flower bed. It's 5 more in the one direction than the other, but they're both mysteries. So they're both x's. Just make one of them an x plus 5. And then we're doing an area. So area, we do 1 times the other in a distributing looking problem. And that has to equal the 300. Again, as we did up above, we need the problem to equal 0. So I would distribute. I'd subtract the 300 over so it can equal 0. And that lets me factor. X and x. With a minus, signs are different. Multiplying to 300, subtracting to 5. We subtract to make this one, the signs are different. 20 and 15 will do that. The plus takes the bigger number. This would tell you a negative 20. You can't have a shape that has negative 20 on the shape, so that's not an answer. This is going to give me 15, which means this side, which is 5 more, is 20. When we threw away the negative 20, and then a positive 20 just sort of appeared, that's usually a sign that you're doing something right, when the negative kind of resuscitates itself. 16, we're just looking to factor and cancel. So 16's first top is a difference of squares, so power cuts in half, signs are different. 16 rooted is a 4 and a 4. Second fraction top, you can take out an x to get x minus 5. Second fraction bottom, x and x, signs are different. Subtracting to make the middle, we'd have to use 4 and 3. 4 is bigger, so that goes with the plus. And then we just cancel. Cancel, cancel. This x can get rid of some of the x squared, but leave an x. The top would have 2 groups of parentheses. The bottom has an x and an x minus 3. 17, we want to flip the second fraction for dividing. And then factor anything we can. The first top is going to go x plus 5, x minus 5, because that's a difference of squares, just like the other one we did. And then we can go cancel, 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 cancel. X minus 5 is all that's left. 18, we want the smallest number they'll both go into, so that'll be 24. 19, we want to go with 20, so that they can both go into 20. And then pick the higher power of the variables. So x is to the 4, y is to the 3. 20, you just want to combine like terms on the top. So 3 plus 4x on the top. The bottom just stays an x. 21, we need to make a common denominator. So remember, when we have these fractions, the top and the bottom each are always in parentheses, even though they're invisible. When we go to pick a common denominator, we need each of these bottoms to appear in the common denominator while we work this out, and it's going to still be there in the answer when we're done. When we do fraction stuff, whatever you're going to multiply new on the bottom, you also have to multiply on the top. So for this fraction, an x plus 3 is coming in on the bottom. So an x plus 3 also needs to FOIL in with the top. And that would get us an x squared minus 9 if you FOIL the top out correctly. I actually copied this wrong, and I'm catching myself. This was supposed to be a minus, so this is supposed to be a minus. So that's a minus. These are minuses. And when we FOIL, this would actually have a little bit more stuff in. For this one, we didn't have the x plus 2, so we need an x plus 2 to multiply in on the top as well. If you FOIL out the tops, it's x squared plus 6x plus 8. And then combining, the positive and negative 6's would wipe out, and we get 2x squared plus 17 on that. 22 is a thing called a complex rational expression. We need to find an LCM, which is x. and go through and multiply each item by that x. When it multiplies here, the x's cancel to leave 1. The 3 multiplies x. Here, the x's cancel to leave 1, minus 4x, and that's our deal on that one. On 23, we need to factor like crazy. So the top is going to be y minus 3 and y plus 2, then a y minus 7, y plus 2, a y plus 2, y plus 1, a y minus 7, y plus 1. And then we think about if this were a fraction dividing another fraction, this bottom fraction would flip. So this is a top, this is a bottom, this is really a bottom, and this is really a top, because that one's going to flip. So we can cancel any top with any bottom. So y plus 2's could go, y plus 1's could go, because those belong one to the bottom, one to the top. Y minus 7 is a bottom, y minus 7 is also a top, we could cancel them. And for our final answer, y minus 3 is a top, y plus 2 is a bottom. 24, we're just going to divide into each term. So if we divide these all by 2's, we get a 10, a 14, and a 16, dividing the numbers. For the exponents, we're going to subtract the exponents and get x to the 6, x to the 4, and x to the 2 in that order. 25 is another problem where we're going to pick an LCM and multiply each term by it. So for 25, 8 and 12 both go into 24, but there's also an x. So I'm going to multiply everything by 24x to cancel the bottom. 8 cancels 24 to leave 3, and x, and that multiplies the top to get 3x. 12 cancels 24 to leave 2, and x, that multiplies the top to get 10x. X cancels x here to leave a 24. Combining like terms is negative 7x equals 24. And then we would just look to divide. The number with the x always goes to the bottom. 24 stays in the top. 26 is about the same. We need to multiply by y because that's the only thing we have on the bottom. When we multiply this by y, it's y squared. Here, y's cancel to leave 6. Here we get a y. Anytime we have y squareds and y's in numbers, we've already done this a few times on the board already, get everything on one side so it equals 0. Since this is positive, I'll subtract it over, and then we look to factor. Y's, different signs because of the minus, subtracting to make a 1, the minus takes the bigger number, so that's a 3, that's a 2. And then our answers are just opposite signs of the factors. Negative 2 is an answer from this, positive 3 is an answer for that. Okay, for 27, we need to turn these numbers into fractions. The idea was if the one person did the job in 4 hours, they could do a fourth of it in an hour. The 2-hour person could do half of it in an hour. When they work together, we're going to add, so that could equal a mystery fraction. To solve that, I would do the LCM kind of technique from before. 4x would be the LCM for those numbers. That 4x can cancel all the bottoms, leaving an x plus a 2x to equal a 4. So combining like terms there, a 3x would equal 4. Divide 3 into 4, you get 1 1/3. I'd rather get 1 1/3 than 4/3 because if we're talking about hours, nobody's ever made a sentence with hours in it and an improper fraction. It just doesn't happen. 28, I would make our normal rate time distance table, remembering rate times time equals distance. It says here one car is 10 faster than another. So the fast car could be something like x plus 10, while the slow car could be x. You could also do the fast car to be an x and the slow car an x minus 10. It doesn't matter. Times are the same, so we can call them both t's, and that clues us in on something about this equation. Since the times are the same, we need to get an equation made where the time is alone. If we need this rate to get out of there, we would divide by rate, and we get d's on top of r's. That's going to help guide us through an equation in a minute. For our distances, the 490, 420, make sure the fast car has the bigger number. So 490 and 420 with bigger number with faster car. And then we're going to make an equation by putting the d's on top of the r's because that says so. 490 goes on top of its rate. 420 goes on top of its rate. And we solve that by cross multiplying. So we get 490 multiplied into x. 420 would distribute this. Subtract the 420, doing opposites always. Divide by 70. And you get 60 for the x, which was the slow car. So the fast car, 10 more, would be a 70. 29, we'd also want to cross multiply. Anytime you have two fractions, you want to cross multiply when you solve. So I already did the cross multiply here. I took the W1 times the D2. I took the D1 times the W2. And our job is to get this alone. So this has to go. So we're doing the opposite. That's multiplying. We're going to divide. And that will go on the bottom when we divide by it. 30, there's three fractions. So cross multiplying is out. And we're back to this use the LCM idea. Looking at the bottom, we can see there's P's, Q's, and F's. We'll have to multiply by all three of those letters. Where the P was, we get a cancel to leave the other two letters. Where Q was, we'll get the other two letters. Where the F was, we'll get the other two letters. We'll cancel the one that was there and leave the other two. We're trying to solve for P, so we need all the P stuff to come together. So this needs to go. Since it's adding, we would look to subtract. We have two P's, and we need to only have one P to be able to solve this more effectively. So we would factor off a GCF. If we leave the P, or factor off the P, it would leave us a Q minus F. This side can just sit tight. To get the P completely alone, now that has to go. And again, it's multiplying. So we'll divide, and we'll get a fraction of that added to the bottom. 31, square roots of 5. We're back to using our friend this table if you want to make the table 2 times 2, 3 times 3, etc. Square roots of 25 are both 5 and negative 5. 32, we would multiply, and for a moment we'd have root 20. But then we'd have to use this table to simplify and think that any of these numbers go into 20. 4 does 5 times. 4 is special because it turns into 2. And under the root, you're just stuck with a 5. For 33, we're looking to just do the roots, leave it as a fraction. Top becomes 5, bottom becomes 4. 34, just combining like terms, 7 minus 5 is 2, root 2. 35, we're foiling, but remember when we multiply root 3 times root 3, that'll make a normal old-fashioned 3. So when we FOIL these, the roots make a regular 3. The 4 multiplies in and makes a 12 total. These two would be a negative 20 from these coefficients multiplying, and a root 15 from the roots. These at the beginning and end would make a root 15, remembering there's an invisible 1 there. These root 5s make a normal 5. This other normal 5 in the mix gets us to 25, but that's negative because of that sign. And then we'll combine like terms. These would make a negative 13. These would make a negative 19 root 15. 36, you just have to remember that the top becomes a power and the bottom becomes what's called an index when we have fractional powers. So this top becomes a power on the x, the bottom becomes the index. 37 is that same thing, just inside out. It'll become x to the 2/5. 38, you need to remember that negative powers flip things. At present, this is on top of a 1. So when I flip it, the 1 is on top, but as I flip, the negative power becomes a positive power when it is flipped. 29, we're just looking when we multiply to add the powers. So copy the 2, add the powers, 7th grade style, make common denominators to add those fractions. 40, when powers go to powers, you multiply the powers. You could either multiply straight across and then reduce, or you could do a little canceling if you prefer. On my paper, I did canceling when I went across. 41 is kind of like 37, that we want to make the fractional powers again. So the top of 41 needs to have a 2/5 power. The bottom has a 1/2 power. The 1 is invisibly there as a power on the x. The 2 is the invisible index that's always there when you can't see it. We're dividing, so we copy the x, and when you divide, you subtract powers. You'd have to make a common denominator of 10. This would be 4/10 minus 5/10. So that's negative 1/10. But then it says in the directions to write this back as a radical. So we're going to have to do a couple of things. One, since it's a negative power, I'm going to write my radical on the bottom because negatives flip things, as we just discussed. X is going to go under there. The 1 should be a power. The 10 should be the index. And I'll just need a 1 on the top of number 41, just like I needed a 1 on the top back on number 38. For 42, we're solving radical equations. We want to get the square root alone, which it is. So I did that for you. And then we square. Squaring a square root just erases the radical sign. Squaring 5 gets 25. And then do an opposite. To get rid of adding 3, we'll subtract 3 to get the answer of 22. Any equation you solve also, it's a good idea to just plug the answer in to check it. 43 is different because there's 2 radicals. When there's 2 radicals, you want to get 1 on each side. So since I saw some adding on the root x, I did the opposite. I subtracted root x to get it out of there. And now we'll square. Squaring the left is easy. It just erases the radical sign. Squaring the right, you have to realize that that full group, there's invisible parentheses there. And if you're going to square that, there's 2 of them that we need to be foiling. So that would get an 81 minus a 9 root x minus another 9 root x is 18 root x plus, because negative times negative is positive, x. If I want to subtract this x, it would nullify that x. What we'd like to do now is get this root alone and square, just like we did a moment ago on the easier problem. So to get this alone, I'd need to subtract 81, so I'd be down to negative 90. I would then divide by the negative 18, so that's a 5. And then the roots alone, so I can square this and square that to come out with a 25. 44, the square root of 16 is normally 4, but since it's rooting a negative, we throw an I on there. 45, if you multiply to get 12i squared, that's pretty good, but you have to remember I squared is negative 1. So instead of 12i squared, you want an answer of negative 12. 46 are 2 things called conjugates, where the signs are different. You could FOIL this out, but that's a longer thing than you need to do. When you're multiplying conjugates, you can just take here, 2 times 2 is 4, take 5 times 5 is 25, and add them together, get 29. That's the quickest way to do that. 27, just switch the sign with the I to do the conjugate, so 2 plus 3i. 48, as written, it's on top of a 1, and I'm asking you to do the reciprocal, so we get 1 on top of what I gave you. And then there's a rule that you're not allowed i's on the bottom. So to undo this, we multiply the bottom by the conjugate, and we multiply the top by the same thing, keeping in mind there's invisible parentheses all around the world there. To do the bottom, I can do the same trick as what I just did on 46. Square and add. 1 times 1 is 1, 2 times 2 is 4, add that up, I'd have 5 on the bottom. On the top, if I do 1 times this, it's just that. But then preferred way to write the answer is 2 separated fractions the way it is on your key. Put 1 over 5 as one fraction. Put 2 over 5 as another fraction that has an I with it. 49, same concept. On the bottom, we multiply by the conjugate because we're not supposed to have i's on the bottom. Everything has these parentheses. If you want to make it visible, feel free. On the bottom, we can do the shortcut. 4 times 4 is 16. 2 times 2 is 4. Add together 16 and 4, and we have 20 on the bottom. On the top, you'd have to FOIL. This would get us an 8. This would get us a 6i squared, which is really a negative 6. So an 8 and a negative 6 would be a 2. Here we'd have a 12i. Here we have a 4i. Together that's a 16i. And then the preferred thing to do here is make this 2 fractions. 2/20ths should reduce. It'll be 1/10 on the key. 16/20ths also can reduce. That's 4/5. And just put an I as part of that fraction. 50 was our greatest thing ever. Just draw the little hats on the C's. 51 is just writing out the quadratic formula. Make sure that the fraction bar is lengthy enough to be underneath all of that top stuff. And the 2a goes on the bottom. And we'll use that sum on this page, but if you can factor, it's easier. So 52 to the bottom, you want to make sure the problems equal 0, which they all do. And then you factor the ones you can. 52 will factor. X plus 4, x plus 1. Change the signs of the factors to make answers, -4, -1. 53 factors, take out an x, that's the GCF. It leaves you x minus 5. Anytime you take out a GCF that involves x, 0 is an answer. And the other answer will be a positive 5. 54 you can't factor, so you could do this formula using a b of 0, but I think it's easier to get the x squared alone by doing an opposite. Since we see it add 4, we subtract 4. And then to get rid of a square, you can do a root. The root of 4 is 2. Root of a negative always involves an I. And anytime you do a root, there's a positive and negative version of that answer. 55, you have to do the quadratic formula, no way around that. So the b is the number with the x squared, which is a -6. The opposite of that would be a positive 6. The square of that is a 36, minus 4 times a is a 1 with the x squared, c is a 2, plain old number is the c, 4 times 1 times 2 is an 8, and the bottom 2 times a, 2 times 1 is 2. Do the subtract to get 28. Square root of 28, I would stroll over here and realize that 4 goes into 28 and can help us. 4 goes into that 7 times. So this should be 2 root 7. The 4 turns into a 2 when we root it. And then the 2 would like to divide into both of those numbers, and it does. 56, the b is -3, so the opposite of that is a positive 3. The square of that is a 9, minus, but since the c is a negative, we'll get a little minus minus makes plus action. 4 times 1 times 5 would get a 20, all on top of 2. The math on that, adding, cleans us to 29, and that's all we can do on that one. 57 factors, x plus 6, x plus 6. The answer would just be -6. Don't write -6 twice. 58 is a lot like this one. I would get the x squared alone and do the root. It just doesn't have an I in it because it's a positive number you're rooting, so plus or minus 3. 59 is about where the quarantine started. There was a video I remember on a few of these problems, page 364 or some such thing around there it was. We let u equal the middle variable piece, and then the problem gets renamed with a u squared and a u. But all of the numbers and signs remain the same. And then we factor. This would be u minus 3 squared, telling us that u is 3. This had a u and this had a u. So we blend those two things together to have x squared equal 3. To solve that, you would do a root. Anytime you do a root, it's plus or minus, and it would be the root of 3 on that one. 60, you'd let u equal, again, the middle variable thing. So what we're going to get is all these same numbers, but with a variable exchange, a u squared and a u. Factor. This tells us u is 6. This tells us u is negative 2. So we want to put this together with that the root of x equals 6. We would try to put these together also, but when this symbol is used, it can only equal positives. It can't equal negatives, so that's a throwaway. To undo rooting, we square, and we get 36 as our only answer. If that's enough info, use that in the key. If that's not enough info, talk on Zoom. See ya.